I've just finished installing the last little bit of an interesting water system here that I thought you might like to see. This is probably the most compact water arrangement you can get. That tank there is a small tank, just about as small as a pressure tank as you can get. This red valve here is called a cycle stop, and I've made videos about that before. This particular situation has the water line coming in from the floor, and this cabin is raised on pillars. So here's the water line here, and it goes down into a 4-inch ABS pipe. This is actually a toilet flange here, and the water pipe goes down, so it's the outside of that ABS pipe is completely exposed, and then it goes underground under the soil such as it is, which is about maybe 18 inches deep or so, all the way to the well. Now that's not enough of an arrangement to keep this water line from freezing. So what we did when we installed the water line is we ran 2 of these heating cables. We really only need 1 at a time, but you're not going to know if it's broken until it's February sometime and your water line freezes up. So we installed 2 at once. But actually, though, the heating cable doesn't have to run nearly as often as you think. And that's what this device here is for. It's made by a company called Inkbird. Those numbers are pulsating just because of the video camera. They don't actually pulsate. But this unit plugs into a power supply here, and it has another plug connection here. So the heating cable plugs into the plug outlet that comes from the Inkbird unit. And the Inkbird unit does 2 things. First of all, it measures the current temperature. So that's the temperature you see here, 8.3 degrees Celsius. That's the temperature at a probe, which goes down here. I've attached the probe to this length of pipe here just so I could push it down to the optimum level. It's just a little probe on the end of a wire. And this temperature here is the temperature at which the Inkbird will turn the power on. Now I've adjusted it ahead of time so that it's going to heat 2.5 degrees higher than the set temperature. So it should kick off at 7.5 degrees Celsius, and then it won't kick on again until that sensor detects a temperature that drops below 5 degrees Celsius. So I could have probably adjusted it closer to the freezing point of 0, but we'll just see how it works. It's working fine now. The power's not on, and I don't want it to be on, but we'll monitor that temperature and see how it works. And I think it's going to save a lot of power. It's going to stop things from overheating unnecessarily down there, and I'll let you know if it works.